So Pravesh is a co-founder of AI Launch Lab, and he's been with the team even before AI Launch Lab existed, when we were Artificial Intelligence Concordia only. So Pravesh Sainath is a PhD student at Mila/University de Montreal. His research is mainly on brain-inspired AI and machine learning methods for neuroimaging. He has a formal background in computer science and AI and experience in the tech industry during his stint at a bike computer startup called Hammerhead. Hammerhead is pretty cool. They put devices on bikes to basically be able to track them, but they're probably doing more than that. I don't know that much about them, but pretty cool stuff. He has worked with and in many projects involving deep and reinforcement learning. He's an educator at heart and is passionate about helping people get started with their journeys in AI. So we're really lucky to have him devoting this much time to helping everyone learn. So let's go to Pravesh. Thank you.
Yeah, thanks a lot, Tim. So I'm just going to share a link on the chat. So this tutorial is going to be different from the previous one. This is kind of interactive. I'll walk you through those steps, but if you, I mean, you're not really obliged to work through the tutorials along with me. You can, if you are more comfortable just watching, you feel free to do so. But if you already are aware of like Python and all these things, this can be a review, but it's not comprehensive. So you can click on the link that I just shared in the chat. I'm just going to share my screen. And for this one, I will keep a watch on the questions simultaneously. It's okay if you don't like complete the entire thing. It's as long as people who are new to Python are getting familiarized with things, understand, I think we are good. And also you can continue the learning of Python on the Carbit platform and other resources. You see my screen? All right. Okay. Just going to open the chat on this side. Okay. Oops. Okay. So yeah, which I see the first question coming in, Python version. So the latest version of, I mean, so I'll tell you about Python. I'll come to the version shortly. So this, if you've not used this before, you should actually have a Google account to Google or like Gmail account to actually run this on your browser. All that's required for you to run is the browser and nothing else, because the computation really happens on Google's backends, like their servers. So this is called the Google Colab, or it is a form of an IPython environment. It's interactive Python. So this is going to be like chatting with someone. You're going to type something. The computer is going to reply something back, but it's not AI per se. It's just it's like the traditional software engineering that we saw in the previous tutorial. So that's how we're going to interact with this. And Python is a very powerful and high-level interpreted language. By some statistics, it's the fastest language that people can learn if they're not from a coding background. So for those who are new to coding and who are just starting out, who are just getting interested in computer science, Python is really a good place to start. So this is the official website. I'll probably zoom in more just in case. Okay. Oops. Okay. So on the side, this is the table of contents. You can skip to the next one if in case you're like aware of the other things, or if you just like to listen, you're free to do so. So this is called the code cell. So this is called the code cell, which has like a play button, which is in gray. You can even change the theme and you can play with this if you haven't used this before. So I'm just going to check the version of Python that's installed. So when you do the first run, if you're not connected, you will see in here that it's running. So like a new CPU is allocated in one of Google's servers, and oh my god, okay, I don't know. Okay, I don't know if someone's remotely accessing my screen, but okay. So the version here is 3.7.10. This is what is currently installed, but the first number is the main version number. Python 2 has been deprecated, which means like it's no longer being used in like mainstream use cases like these. But even in Colab, it's deprecated, but there are ways to actually use the earlier versions. But it's always a good practice to stay up to date, use latest versions like we do on our mobile phones and apps. So, okay. So this is the current version which is installed, but there are options to install specific versions if you want, but let's stick to this version and go ahead. So anything that we run in this code cell that starts with an exclamation mark is actually a bash command. If you don't know that, it's fine. It's just like a similar chatting system on the terminal or the terminal of a Linux-based system. So I'm just asking the system which version of Python, this is the option, which version of Python have you installed? And it just tells me it's Python 3.7.10, and I'm good. So let's start. So in any programming language, in any language per se, we start with ABCD or ABCD. So here, if you're new to any programming language, we start with variables. If you're aware of other programming languages, you don't need an introduction to what these are, but you can just relate to the notations of this language. So variables are basically storage spaces which are named and given specific values. So here you can see A equals 1, B equals 3. When we do math and when we do any kind of computations, these are necessary to do further processing. So we start with integers, and I'll go a little bit fast in the first few sections because it's very simple, but feel free to ask your questions and if you're very new to Python later, okay? So I'm just gonna say A equals 1, B equals 3, and this is the print statement to print different things. It's separated by commas. The first item to print is a string. I'm just putting it there to know what I'm printing. And the second item is A plus B. A plus B is 1 plus 3 is 4. A minus B, 1 minus 3 is minus 2. And this A slash is divide and A star is multiply. The A slash is divide and A star is multiply. A double slash actually means integer division or modular division. So you can see here that A is 1 and 1 divided by 3, which is supposed to be, I can just print that thing here. I can just say 1 divided by 3 and it's 0.333. But if it's 1 slash 3, it's just 0. It just takes the integer part of the answer. This might be useful in some cases where you need to really restrict your loop or something. So next is the power operator. B is 3 raised to the power of 4 is 81 we have here. And next we saw integers. We're going to see numbers with decimal points because that's how life is. It's not perfect. So 1.0, 1.678, and we print F. So anything that any variable can be the last item on this cell and it's directly printed. But in case you have to print multiple items like these, you'll have to write these print statements or add multiple print statements. So let's continue. So floating point division is just dividing 1 over 2. So if I just get rid of the decimal points here, it's still considered floating point. because that's the default data type of this division. Similarly, when I do 4 divided by 2, it's 2.0. Okay, and you can even work with complex numbers in Python. If you've never heard of complex numbers, it's fine. These are just like higher dimensional numbers. So this is how you specify it, like 1 plus 1j. J is the notation. And then, so I see a question, what happens 1 over 2.0? It's 0.5, that's right. You can definitely like try those different things and see. But these types are pretty straightforward. And so Booleans are variables which have only yes or no type, like true or false values. And in Python, these two values possible are true or false with a capital letter, starting with the uppercase letter. So the different Boolean operations that are possible when it's true or false are, and, not are the basic ones. So similar to the addition example we saw here, we see those values here. If you don't understand what these things mean, true or true, false or true, false and true, don't worry. But this is how you combine two different logical elements. So I'm not going to get into those details, but just so you know that you can assign true or false. The next is strings. So strings is a string is just a sequence of characters. Of course, strings are everywhere, and when we have to work with text processing and all that, we need to work with strings. In Python, these are specified with the quotes. You can use single quotes or the double quotes as you wish. We'll see some cases where one or the other quotes make sense, but in most cases, you can see here S equals N, because you can see the double quotes we use in the print statements. We've already been using strings. These are string constants, and I'm assigning a string value to a variable S, and string comma S is, you can see string and N, and I'm just replacing this with single quotes. Yeah. So again, in terms of Python version, in this case, I'm using the latest version which Google gives me through this platform. But when you work on a project, again, it's suggested to use the latest version. But sometimes when you work in like complex projects, you need to think about compatibilities with other libraries. So you might have to tone down your version so that you get to use the other libraries and packages for your project to be complete. And then single quotes can also be used. So this is a string too. Nothing's printed because I'm not printing. I'm not explicitly stating anything. So if I put A, I'm just getting the string. So if you have like super long strings, you can split strings like these through these parentheses, and you can see it's all combined into one. Sometimes it's better to use these notations so that the code is readable by others. And they understand what you've written. And next one is a multi-line string. It's similar to this. This is another way of specifying. Instead of just one pair of single quotes, we use 3 pairs in this fashion. This is a multi-line comment, and this is a multi-line string. And you can see A prints this is a multi-line string. So the difference between these two cases is that there's no this weird looking /n. If you work with other programming languages, you know what that is. It's a new line character. But when we want to explicitly encode a new line character in the string, we use this. When we don't want to include it, we use this notation. This is a comment which is meant only for reading purposes, as in many other programming languages. It's a good practice to include them in your code so that it's this is a single line comment. This is a multi-line comment so that it's readable, understandable by others who work with you, especially if you work in the industry. This is a very good practice to have. And it's a very good practice to have even if you're coding during your holidays. So this is an error because this is an EOL, which is the end of line character. So this you're not supposed to, like, just because you can specify multi-line strings, you're not supposed to specify them in this manner. There are like certain rules that the interpreter expects for it to make sense. So you just have to use one of these two notations to get rid of this error. This error is just given for you to make note that you cannot like continue words as we type in our word processing software. So this is yet another multi-line string where you explicitly code the /n. When you work on NLP, natural language processing projects, these things might make a difference. How you would like to process the text and tokenize, like splitting them into words. But this is just a pointer for that. And then concatenating is an operation in strings, which is used by the same plus the addition operator maybe you saw in the integers. So str plus ing is string together, they're together. And again, this is the same thing used with different variables. So some other, okay. There are many other useful methods related to string because the operations are not straightforward as we use in math in the case of the other numerical types. So this is a method which is used for you can actually use it for many different classes, okay, we'll see what classes are, but many different cases. But this is the set of properties, or these are the set of this is the set of methods which are available that are possible with a string. Just ignore the underscores for now. So dir basically prints all the methods. So it's actually object oriented. I haven't come to that section, but for now, let's say that it just prints the possible methods or operations with the variable that you pass in the argument. So dir of a means list me all the possible operations with a. So these are the different operations, and there is a link in the first cell. You can read through the documentation to understand what these different things are doing. And also, I'll show you one more thing on Colab is I can just say a is a string. A is a string, right? So I can just confirm a is a string. A dot, and if it just is a dot, and some in some computers it's like control space or command space. You can see the list of methods that you can use. I can just say lower, and I can call, and it's lower. It's nothing because a is an empty string. So let me just set a equals q, the lowercase, sorry, the uppercase, and a dot lower prints the lowercase q. So these are, you can see the lower thing listed here. So these are methods that you can use to transform the string into different ways. These are very useful when you do natural language processing as well. So next is after dir, we are seeing something called the type, which is present for every variable. To see the type of a is a. You can even like say like p equals 1 and type of 1, and it's integer. P equals 1.5, and sorry, type of p is float here. So type is another key if you're if you're reading someone else's code and you're struggling with what type it holds, because Python is dynamic, like it does not have like an explicit type to be declared as in many of the programming languages. It's inferred dynamically. So a dot length, this is another method. So this again is from this list. You can see there's this method. I know that the underscore notation is crazy. Underscore notation is crazy, but this is meant for like private stuff, which we'll see later. So somebody asked me to do this. This is an error because You cannot add a string and an integer, because for the string, the plus is a concatenation operation. For the integer, the plus is an addition operation. These two are not the same, despite us using the same operator. So this could possibly work. This is what you need to use. So length just gives you the number of characters in the string. So A is actually a string right now. It's string. There are 6 characters. There are 6. So this is the length function. And then, yeah, that's exactly what printed there. So this is equivalently done by calling len of A instead of a dot len. These are 2 different ways of doing the same thing. But this is the most commonly used way, len of A. This you can use for many different types that we'll see before. And this is called the escape character. So you can just print this word. This is a French word which has this punctuation. And if you need to retain this single quotes in the punctuation as a part of the string, you need to escape that character. Like you need to, you can see that the slash didn't appear in the printing. You just need to say that please ignore, please consider this quotes to be part of the string and don't end the string. If instead I do this, you can see the color changing already. This is an invalid syntax. So in these cases, you should either escape this, or the other way of specifying this is using the double quotes for the end, and you can still use this. So yeah, and then these are other methods. I'm just going ahead faster. That's pretty obvious. You can even look through the documentation that I shared in the first cell. You can just search this on like Google or something, and you'll get what the arguments of the function are and what the function is actually doing. So here it's just checking if the string s, which is hello, ends with L in the position if in the index 3. So let me just do one thing. So ends with, you can see the documentation string appearing here, suffix, start, and end. So the first one is the suffix. So if it has L in between these indices, so H is 0, E is 1, L is 2, and so on. And if it has L, that's the method here. So you can just look at the documentation and play with this. You'll understand this. Let me go ahead to the next section. So this is called the format specifier to really substitute other values into the string. In this case, the braces here. This is everything is considered as a string when it's plugged into these plugged into this string. And when you specify specific formats like these, it means just retain 2 decimals. Don't give me all decimals. So this is another way. These are useful when you produce results and plot stuff and all that. So format string for so this is to directly add them. This is just a fancy thing for people who are already aware to just be curious about. Okay, now let's get to the main part. So in this tutorial and in machine learning in general, with Python you can do many things. You can do graphics. You can design web web apps and so many other things. But our focus would be limited to giving you the power to apply machine learning, to use machine learning packages through Python and solve your problems and work on your projects. So we're going to look at some basic data structures because we're going to deal with data, right? Machine learning, we just saw we have to deal with data. So all these A, B, C, and like all these simple variables are not really sufficient. Strings are kind of okay if you're working with text, but When we have like we saw like a table in the previous workshop with like the Celsius and the Fahrenheit. So we need to work with like bigger structures which can hold a lot of data. Like one, we saw that like one sample of sound could be like a train of values like these. So we need to really use structures which are able to hold these values and perform. We're able to perform the operations that we like on them. So these are the basic data structures which are present. But ultimately, in like machine learning frameworks and in modern libraries, you don't really use these data structures, but the idea begins from here. We use like more optimized structures, which we will see later, or we'll figure out later through the Corbett courses. But this is a list. A list is just a collection of identical items in a sequence. So this is the word probe, P-R-O-B-E. This is similar to the hello example that we saw, but that's a string. In this case, this is called a list. And you can see that the length of the list is 5. And the index is 0. Index, again, the computer scientists, we count from 0. We start from the basic. So 0, 1, 2, 3, 4. And there is this concept of a negative index in Python, which is very useful, which makes things cleaner. We'll see how these are. And you can index the array, the list from the end. It's -1, -2, -3, -4, -5, which means the number of positions from the end to like basically go in the reverse direction. So array, this is an example array. This square braces are used for specifying lists. They're equivalently called arrays as a concept, but they're of type list in Python. So array equals like this list, and I'm just printing this list, and this is the same thing. It's just a list of numbers. And we saw type was a handy tool for us to really figure out what is this type. So type of array, we see it's a list. So this is the list data structure that we're looking at. And we can actually do the same thing that we did before, dir of like my list is array. So dir is like your helper.
dir, c'est un peu c'est notre aide en fait qui nous guide un peu à savoir ce qui est accessible comme fonction.
But you can see the operations say append, clear, copy, count, extend. I mean, you need not really know what these do exactly at this point, but that actually gives you some sense of what it may be doing, right? For example, remove should probably remove something from the list that we created. Reverse should probably reverse the list. So we can do those things. So again, I'm printing array to remind ourselves. And let me just use array. And the way to use these methods is dot reverse. And you can, reverse is like, it's called an in-place operation. So you'll have to print the array again. And you can see that the array itself is reversed in the same variable. So the most important idea for any for any machine learning library that you use is this idea of indexing. So we saw the index values here, and when we address this as a whole, we use the entire variable. But here when we have to address a single element, we're just going to use the index value, which is the same square braces notation. So we see here that array of 1. Before, okay, I think it's better. Like I wanted you to actually guess what is array of 1. It's 6 because we count from 0. 5 is 0. 6 is 1. So array of 1 is 6. And again, we saw type of array to be list, but let's see what is type of array of 1. So array at position 1 is an integer. Of course, this is an array of integers that we created in the previous step, the previous code cell. So this is of type integer. So a list is nothing but a sequential collection of other types. In this case, it's an integer. So this indexing is not just single indexing. You can even index a subsequence from a list. For example, array. This is called the colon symbol is the notation to really specify a range of values. So 1 until 5 actually gives us 6, 7, 8, 3. So we saw here that the index starts from 0 and ends 1 minus the length of the array. So let's look at our array in hand. Our array is 5, 6, 7, 8, 3, 2, 4, 1. And if it's 1 to 5, so we don't consider 0 because it starts from 1. So it starts from 6, 7, 8, 9. Sorry, 6, 7, 8, and 3. And it stops here because the next index is supposed to be 5, right? 0, 1, 2, 3, 4, 5. Let me use this. Yeah, this is supposed to be 0, 1, 2, 3, 4, and 5, right? So this basically wants us to select elements from 1 to 5, but 5 is not included. The Pythonic notation really doesn't like the upper limit. It considers just before it. So it's just Python's way of doing things. So we start from 1, start from here, and just before 5, I stop. So this is the array that I should expect in the output 6, 7, 8, 3, and that is what we get exactly. So let's continue. So let's look at type of array of 1 to 5, and it's a list because it's a subsequence, right? It's a sub list of a list. It's not a single number like array of 1. It's a list in its own right. So these are like some cool things with Python. It might sound silly at first if you're new to Python, but they're very useful in making your code look smaller and obvious. So endless slices take their prefixes. So the default prefixes, like if I don't specify anything, this is a range as I told you before. Here we have specified it to be 1, and here if I don't specify anything, it's just gonna plug in the value 0 for the upper limit, and it's gonna plug in the last value for the lower limit. So you can see here that this entire list, if I don't include the lower limit of the range, it takes from the first element. If I don't include the upper limit of the range, it takes till the last element, right? So far we've seen a list, how to index a single element of a list and what these types are, and how to index a subsequence from the list. So now let's progress further. We saw a of 1, we saw a of 1 colon 5, we saw a of colon 5, a of 5 colon. So these are different. This is called list slicing. Actually slicing, it's like a loaf of bread that you slice the two ends out. So there's a third argument to this slicing, which is very elegant. It's called the skip. The skip basically jumps. So let's just yeah. So let me just reinitialize array here. So I'm just gonna do the same thing. Like let me index my 0, 1, 2, 3, 4, 5, 6, and 7, and start from 2. So I'm just gonna start from here and end before 7. So this is 7, and I'm gonna end here. And third term, so this is start, this is end, and the third term is the skip term, which is 2, which means start from 2, jump over 2 elements, 4, jump over 2 elements, 6. Doesn't this remind you of your primary number line addition or something. So this is supposed to give me 2, 4, 6. Let me check if that's the case. It's currently different because it was a different array. So let me run this again. Sorry. Oh, sorry, it's 2, 8, 6. I counted this before. This is 8. So it's 2, 8, and 6. Okay. So it's 2, 8, and 6. So you get the idea, right? So if you have to skip, this is called a skip value, or like you're basically jumping across the index values. So you get this. And one more interesting aspect of lists is that they need not be elements of the same type. It can be a mixed bag of different things. So the length of like 1e. So this 1e minus 8 is like a scientific notation. This just means 1 multiplied by 10 raised to the minus 8. So so this is just to show you what it is. 1e minus 1 is 0.1 because it's 10. It's 1 raised to 1 raised to minus 1. So yeah, this is 1 times like 8 decimals before 1. So we can even like check it out. Oh, it's okay. There are formatting functions to print them as they are. See here. Okay. Yeah, these are useful to like ignore a lot of zeros and zeros and zeros. So to recap on list, these are sequences which are indexed, and you can specify the index value, or you can specify a range of values. You can skip the lower and upper limits if you want to. There are multiple. I'm not getting into these, but you can try out these things. You can just look through the documentation as I just did. Like like array. Just say array dot, and like try out a random function like extend. Okay, extend is not iterable. Okay, insert, right? Insert. You can see insert. You can see the signature here, index and object. It's very obvious, but if you really want to know the description, you can read it here, or you can go to the documentation link and see it. So insert index and object. So we saw the index was up to 7. So I'm just inserting something at position 6. And let me insert something crazy so we can actually spot what it is. Like let me insert a star. And I insert a star at the 6th position, and I print the array again. And you can see here that before the index 6, at the index 6, 0, 1, 2, 3, 4, 5, 6, a star is inserted. Yeah. When you work with data, when you have to like shuffle your data, you do a lot of things to arrange them in a certain fashion. You can make use of these operations. But I mean, you would use different structures for machine learning, but this is the basic idea behind that. A lot of these functions might come in handy at that point. Okay, we saw subsequences, we saw, yeah. So now let's move on to like more complex structures. This is like a single dimensional list. There's just a single line, linear, single line of values. But what about values which are, which are on 2 different directions? Or in other words, 2-dimensional list is the opposite of insert is actually remove. I think I can do this. Like, let me print out the array just to be sure what it is. And array, you can just, let me say I don't know the method. I see only the remove is the opposite, because you insert and you remove. And remove, and the signature is just the value. So I just have to specify the value to remove, right? And let me print the array, and the star is now removed, right? So it like, not just with respect to lists, but any other structure like this will definitely be very self-explanatory. It's about just applying the right parameters and understanding what it does. In most cases, the function that you want is already implemented there. Okay, so let's just look at a 2D list. The 2D list is just a list of a list. It's 2 dimensions because we'll see why it is the case. So A is you can see instead of just a comma separated values, it's a comma separated lists which are combined together. It's a list of lists. So A equals this one, and let's print A, it's the same thing. So this is, you can imagine this to be like a matrix form, like 1, 2, and 3 in the first row, and 4, 5, and 6 in the second row. So let's just print what A of 0, A of 1 actually give here. They actually give you the entire list, because A of 0, this is A of 0, and this is A of 1, right? And inside A of 0, we know the index rules again. So it's 0, 1, 2. And this is an independent list. And again, the indices are 0, 1, and 2. So you can kind of combine these two indices and use them as 0, 0, 0, 1. Like 0, 0 is 1, 0, 1 is 2, 0, 2 is 3, 1, 1 is 5, and so on. Okay. So that's what we're going to do here. So we just printed out the single index values, which are lists, or in matrix terms, you can call them to be rows. So when B equals A of 0, the entire array or the row is assigned to B, and B equals B. And we're just going to print out the second value in this array, which is supposed to be 0, 1, and 2, which is 6. So let's see if we're getting B equals. It's a good practice when you practice these things to guess what you'd expect rather than like not really caring about it. So B is the entire. Oh, sorry. I think I was wrong. This is A of 0. It's not A of 1. So it was 4, 5, and 6. Sorry, it's 1, 2, and 3. And 0 of 2 is, this is 0 already, A of 0 already. And the second axis, it's 0, 1, and 2, which is 3 here. So it's 3, right? So in the next two cells, we're just going to modify some value like 0 and 1. This is A of 0, and 1 is the value 2, which is going to be replaced with 7. And we're going to see what is the change in A and B. You can see in both cases that the 2 here has been replaced by 7, which means that B equals A of 0. You're not here, you just modify A, you're not modifying B. But despite that, B, the value of B also changes, which means that they're actually sharing the same location in the memory. The change in one reflects the other. They are soulmates, kind of. So again, B of 2 is 0. B of 2 is supposed to be, B is supposed to be A of 0, which is 1, 2, and 3. And B of 2 is supposed to be 3. Like even in this case, B of 2 is supposed to be 3. And if that's 9, and it reflects even in A of 0. So these are the same thing. So these are some things that you need to be concerned, you need to be careful about when you process with multidimensional data. And you'd use different kinds of libraries like TensorFlow, PyTorch, or of that sort. But the idea there is based on this kind of, the notations are like similar and the ideas are similar. So you need to be careful in understanding how these operate. If you don't understand them perfectly right now, it's just okay. This is just iterating through the list. So I'm just going to skip over. We've just got 4 minutes. I'm just going to skip over to one important section, which is useful. You can work through the exercises and the other sections in your free time, and please keep your questions posted. The Carbit exercise Python chapter is also really good that I saw. So these are maps and tuples, which are other. And keep your questions coming on the chat. I'm taking a look at the chat. So the maps and tuples are like other kinds of data sets which you can maintain something like a directory, like a dictionary. Map is basically a dictionary in Python. Like name is Bob and age is 25. And instead of the square brackets, you use the curly braces. And this is the notation to actually specify the values. The operations are similar. I recommend that you go through when you have time. And tuple is just an immutable list, which means a list that cannot be modified. It might seem redundant, but it's really useful in some applications. And there's another data structure called set, in which unique, I mean, in lists, you can have the same item repeating because it's sequential. There is a notion of index. In sets, if you add like cat again, there's just one entry of cat. There's no ordering involved. It's similar to what we see in math. These are useful in some cases when you're using some data sets and finding unique occurrences or repetitions or something. Okay. Yeah. So we'll continue with this. Apparently, there's time to 3:15, but you can keep posting your questions if you have any. I'm taking a look at the chat as well. So the structures are pretty easy. You can just like look at the documentation of some structure. You can even define your own structure as you wish, and go ahead. And so then the next important topic is like control flow, which if you've used any of the programming language, you know how important this is. If you're new to programming, you will now know why it's important. So this is just a sample code using something called the if-else structure. If-else, it's very obvious in natural language terms. So the question is, can you put other variable type than a string in a set? Yeah, I think this. I think sets are also like type independent. So I can just say set union 1. See 1. So sets are also like lists. You can like add unique elements to them. Okay. There's no ordering, but you cannot iterate through them through like a loop over them or something, which we will actually see now. So if else, the first line actually takes in an input from the user and converts it to an integer. If a is greater than 6, then print a is greater than 6. If else if is elif in Python, a is less than 3, print a is less than 3, else print a is between 3 and 6. And please note the 2 things to note here in these control structures. The first thing is the colon. We saw colon in the context of a range specification in the list, but here it's meant to terminate a condition and start the next line. When you start the next line, it goes to a different indent. You can see the lines here. Like in C and C++ and Java, Python does not use braces because it's cumbersome, but indentation is kind of neat, but it's sometimes annoying if you're really new. So you can see here that print, if and print, it's if I just press enter, it's going to the next level, but the other prints are in a different level. So I'm just pressing tab and it's going to the next level. You can see all the 3 prints are aligned. This will now prompt. So this is the prompt for the input. I'm just pressing number 7, a is greater than 6, which means only the if case has been executed. The other cases have been ignored because they don't satisfy the condition. Again, let me run this cell again. I'm pressing a number that is 4, and you can see a is between 3 and 6, which means this else case has been executed. The other 2 cases have been ignored because the conditions are not satisfied. So this is the basic branching. You can try different things and just be mindful of the colon and the indentation. If you just skip the indentation here, like for example, if it's here, it's gonna prompt in actually after I enter this. Oh, sorry. I think this is not flexible. This one should be problematic. Yeah, this is problematic because indentation error expected in an indented block. This is a common error that a lot of newbies to Python face. If you use the right kind of tools to code, you wouldn't really face them. So yeah, so 4 is between 3 and 6. And this is like a conditional structure, is if else if. This is a loop. So I see a question. What is this? what is the type of a set? Just like an array, it's a set. You can always do this type of animals, and it's a set like list. It's a data structure which is composed of multiple different types. Okay, so loops is just like a conditional structure, but it goes over multiple times. So for so I'll probably print like a simpler loop for those who are new to loops. So it's for I in okay, I'm just going to say for I in range is a function in Python, range of say 5, print I. Just going to print 0 to 4. Range of 5 is similar to the indexing that we saw. 5 actually means 0, 1, 2, 3, 4. That is, it's nothing but 0 to 5, because 5 is excluded in Python notation. So print I is 0, 1, 2, 3, 4. And similarly, enumerate is another function which is kind of doing what range is doing, but instead of taking the natural numbers, it takes in anything that you give, any list or any data structure which is iterable, which is countable inside the arguments. So there is this question, a equals int of input does not work. Yeah, there is a braces. Usually the compiler, the interpreter itself would tell you that. So for I comma j in enumerate basically takes each element in the item that is given and appends it with a number. Let's see what is being printed. So I comma j, for I comma j in enumerate, so 0 is the first index, which is 0, 0. 1 is the second index, which is 1. And it just like, it does some sort of just a counting. This is useful again when you run your training loops and when you do machine learning, and to really track. We saw epochs, right? To really keep track of which epoch you are in while training. And these are other handy functions which you can see the documentation to understand, like range, we just saw, enumerate, we just saw, and zip is like a zip operation like we have in our clothes and bags. It combines two different data structures which are iterable, which are countable, and pairs them horizontally. You can see an example here. Okay, M is not defined because I didn't run the previous cell. But okay, that's not very important. So how does enumerate change the values in the list? That's the question. Does enumerate change the values in the list, or could you still print elements without an index? Yeah, enumerate does not change. So most functions in Python do not tend to change the values in the list, except those which are called as like your list variable dot some function. So in this case, enumerate does not change, and your other part was print elements without an index. Yeah. So this is the loop for I in. When you loop through the list, you don't specify enumerate. You just say a list is by default iterable in Python. So print just like for I in cat comma dog, print I. It's just going to print cat and dog. You can just print for I in. You can just say for I in array, print I, it's just going to print all the numbers separately. So enumerate is just like this extra column, like a serial number that you add. Yeah, similarly, you can try out a zip function and see. This is not very useful, but you can see if you are a fan of while kind of structure. This is similar to for, but you can have separate conditions spread out under the execution of the loop. So while this condition is satisfied, the code underneath, so in this next indent, is repeated. And you can see stop if I, this is a reminder, this is a modulus operator. So if I is a multiple of 10, then stop. So we're starting from I equals 10, I plus equals 1. And if I is a multiple of 10, then stop equals true. So you can see here that it takes in one more iteration to actually complete it. But you keep your questions coming in as and when the things that we do. So next part is functions. It's most things that you implement when you good coding practice is to really decompose your code into functions, which are like separate parts, so that you can understand what is done when, instead of a single long like a huge paragraph. So this function is supposed to like, this is the syntax. You start with the def, which is a keyword, and you give a space, and then you name the function, and you specify the argument. So this is similar to what we've been using, like append, reverse, like len, dir, and everything else. But this is how you call a function. A function is like a separate piece of code, which is invoked, which is written separately, and you can invoke the function when you use it. So the len and the dir functions were implemented in the Python library itself. So this is a function. This is called a user-defined function, which we define for our purposes, which makes sense to your code base. So def is odd. I'm just saying this is going to say if the number that I pass is odd or not. So return a mod 2 equals 0. So remember, the conditional comparison is double equals in Python. If again, you'll get used to these things, but just remember, this is not the same as single equals, which is just assigning values like here. Stop equals true. It's not assigning values into the left-hand side. It is just checking that the variables are checking that the two sides are equal. And this is the reminder operation. Okay. So yeah, is odd is supposed to return a conditional, like a Boolean value, because this is a conditional operation. Is this equal to 0? Is when I divide a by 2, is the remainder equal to 0? That's the kind of the script of this function. Yeah, I'm good to stop. Yeah. So yeah, so you can play with these different functions. This is exactly what we saw before, and you can try playing with them. There is this construct of lambdas, which are interesting, which are just ways of specifying a function in a single line. For example, in this case, you can see lambda. I can just rewrite this here. Lambda x comma y is equal x comma y colon x star y, which I'm just going to call this mul. Okay, this it just means you can just invoke mul of like 5 comma 6, and it's going to be 30. This is just a short way of specifying functions, and you can call functions of functions if necessary. And exceptions, you can take a look. So do you have any other questions before I just tell you about an interesting feature? This is called the list comprehension.
Yeah, go ahead, Pravish. It seems like, the questions were asked and you're giving a really interesting and useful content. So maybe last few words from you before we can send people to the next portion of the session.
Yeah, so I'd recommend that you take a look at the list comprehension. This is just a looping over, compressing the loop into the list and creating the values here. So you can see here things like these, and I'm just going to skip this if, and you get these values. So yeah, so if you're new to Python, I recommend that you spend some time with it. No language is learned in a day, so spend some time with it. You can go through the content, you can go through the Carbit courses, you can go through the resources which are linked here. You can solve some exercises on these links, and it's addictive actually for learning and solving these exercises. So I'd recommend that you work on this, and that's a good starting point for you to get started on the machine learning project. And thank you everybody for your questions and your patient listening.
Thank you, Pravish. You're the one giving us such generous content. We're very, very lucky to have someone like yourself to share all these great insights. I think all the participants have a lot of great quality feedback to give back to you. So thanks really a bunch. It was a pleasure to have you amongst us today for both workshops you provided.